but I would like we start from there. So if you look at program development, there are some things that we need to use or to have, and maybe I can explain that using the PowerPoint. So in this case, we need to understand that we need to start from somewhere. That is what you call the program definition. Program definition. Then from the program definition, we need to have what you call analysis. And then within that, maybe you can have what you call analysis. Maybe you have design. Then after design, we have compilation. We compile. Then after compiling, from design, you code. Then you compile. Then from compiling, you test. Sometimes we say it's called testing and debugging. Then from testing and debugging, maybe we can do what you call implementation. And the moment we talk about the first one, which is the program definition, we always say that we identify a problem. Like now, if you go to the management system that we use, maybe there is a problem. Maybe we say online registration. That is a system that we have, but there is a problem of registering. There is a problem of registering. And if there is a problem of registering, now you have to look at now what are the things that is that are making that program not to execute the way it is supposed to execute. What are the issues of the executions? And then if you come up with that, now you can go and do some analysis. So that is an identification of a problem. Then when I identify that as a problem, then you have to ask yourself, how will I rectify it? So for you to rectify that problem, that is a point where now you do what you call analysis. And in programming, when you say analysis, this is when you set variables. You set variables, and maybe you set the types that you're supposed to have. Maybe you set the information or the message that you should be able to communicate, which is that message that you're supposed to communicate. And in this point is where you ask people questions, maybe they respond to a certain point, you define the variables that you can use. When you define those variables that you can use, that is when you take the system in a diagrammatical presentation. And this diagrammatical presentation is when we use what you call a pseudocode. If you can remember what we said about a pseudocode, we said a pseudocode is an English-like statement. It's an English-like statement, the way we can write some statement from one to another sequence, in a sequence way. Or you can use what you call a flowchart. You can use what you call a flowchart. At the moment you're using this kind of a presentation, now you must always be able to understand that the presentation of this code that we have, how will you be able to present that using a diagram? And within this presentation using a certain diagram, now we use a flowchart and we'll be able to look at this. Then when you look at coding, this is when you take it to the programmer. The programmer now interprets it in a given programming language that the user can be able to, the system can be implemented. But when you are coding, you must compile. You must take all the calls, then you connect them together, then they execute some information. And then after that, you'll be able to look at now the program is able now to execute different types of executions. Then after that, you can test. When you are testing, we are looking at the issues or maybe the problems that are arising within the program. Then you correct them. So debugging is correcting the errors. Identify the errors, you correct those errors. Implementation is where the system is in use. So I want us to go back to the design, and I will use Paint. And when you go to the design, the first thing that we need to understand is that we must use a start button. Sorry. So we are using, if you look at your notes, I don't know whether you can see the notes. Let me see whether I have those notes. Mhm. If you look at these notes, they are symbols that are mostly used on a design, and I think that is where we were supposed to start. If I'm not wrong. So this is the first symbol that we are supposed to use. I will show you with the diagram. We are supposed to use it as a start and end. There is a process which represents the operations or what we are doing with the system. Maybe it is registering. We can say registering the student. This is an output or an input. The moment I want to have an input value, I can have this. Then I have decision, where you might be having two alternatives, and those two alternatives that you are having, now you have to select one. You cannot select two alternatives at the same time. You have to select one at a time. Then we have connectors. Remember, the moment you are trying to come up with this design, you might be using a certain space, but the space is not enough. So you have to look at now connecting them. At the moment you are connecting them, we use what you call connectors in the system. So in this case, there is a program that is here, but I don't want us to use programs that is here. I want us to come up with our own programs. And the program that we can use, allow me to use this. The program that you can use, maybe it is a program that adds two variables. So the moment you're adding two variables, the question that you are supposed to ask yourself, how many variables am I supposed to have? Those are two variables. Then the next one is supposed to be a sum, because you are looking at now, it is sum is equals to A plus B. A plus B. So these are two variables plus this variable. So in this case, I require an input of A, I require an input of B. So in this case, when you're using a pseudocode, we always have a start. Then from a start, we can say declare the variables. Declare the variables. Then after that, you enter. Remember, we must define which is this kind of a variable that we are having. Is this an integer type? That's why we have said use variable. That is design. Enter the two variables. Then after you enter the two variables, what are we supposed to have? Maybe calculate the sum of the two variables. Calculate the sum of the two variables. Then after that, display the sum of two variables. Display the types of two variables. Then after that, you can add. So in this case, you can understand that the program that we are having is written in a pseudocode. So this is what you call a pseudocode, an English-like statement. An English-like statement. An English-like statement. But is it possible for you now to convert this concept here in a manner that now we can use a flowchart using a given presentation? So allow me to copy this code the way it is. Then after that, maybe I use Paint. And maybe I can paste. I don't know whether it will, just a minute. I don't know whether it will copy. So let me use sniping tool. Maybe I don't want to, maybe to keep on referring. I want to use it when it is in a given point. So allow me to copy that, then I paste it on a paint. Oh, then I paste it on a paint. That is now our code. But we want to interpret this code that we are having here, but to interpret the code using a flowchart. So the first thing is now to have a start. Remember, when you're using this, you'll understand because I'm scribbling start. Then from there, we have said declare those two variables. So when you are declaring that, that becomes a process. Because if you look at our notes, we have said it's used to represent operation on data, e.g. computation, details are written in an, okay, it's used to present operations. So most of these operations are the one that we are creating here. So we use a rectangle. Allow me to use that. Then we can declare variables. So you allow that. So we declare variables. Then after you declare variable, what are we supposed to do? We are supposed to enter these variables. So remember, when you're entering this, we have to use this symbol. Enter two variables. Then after that, you calculate the sum. So when you're calculating the sum now, it becomes a process. So calculate a sum. I think you can understand that. Then we must display. So in this, we are using this as a flow. So this is a flow. This is a flow. So within this, we can have another presentation, which is an output symbol display sum. Then what we are saying is that because now we cannot end at this point, that's why I'm saying we connect. So we can use connector, and from our connector, then we can now add. So that is now the connection, of which now I can add at this point because it was able to feel like that. But now because I wanted to show you on how we can use the connector, that is how it's supposed to be used in our presentation. So if you look at this question, we don't have a decision. We don't have a decision because we don't have those decisions that we have. But I would prefer maybe we use decision the moment we'll be looking at maybe a control structure. That will be the next class that we are supposed to start with, so that we can understand on how we can be able to write these programs given the scenarios. So I think you can understand. Can you understand that? Can I continue? Yes? Akinyi, can I continue? Can you understand the question? If you're not understanding, can you tell me I repeat the question? I repeat the presentation. So I'm expecting you understand. If you are doing a diploma, you are okay. It's not like a certificate student. So can you understand what I'm teaching? Okay, so I can start from. So let me start again. So if you look at the first thing that we were saying, when you are looking at now designing, remember we have not started coding the program because we have not looked at the steps of or the structure of a C program. That's why we are not coding. And I have said we can start a program maybe using a pseudocode. Maybe you can be given a program, and this program you are supposed to write a pseudocode for this program. And because we are using a certain paradigm or we are using a certain procedural method, we have to move from the first to the end. So that's why I'm saying what we need to look at in terms of presentation, we have to look at where are we supposed to start. So can you note that we are starting? So that's why we must show that we are starting a program. Then from starting, what do you do afterwards? You cannot use a variable that you have not declared. So you declare that variable. Then when you declare that variable, what else can you do? So at that moment, you must enter the data. Because now you know the variables. Do we have the values? No. Enter the values or enter the two variables. So you're telling the programmer, you're telling the compiler, I want to enter these variables. So when I enter them, what am I supposed to do? Calculate the sum. Then I display the sum because that is our main aim. So a program that adds two variables and maybe add displays their sum and displays their sum. Maybe we can interpret in that way. And that's why I've said that if you use this program and now we want to use a flowchart because this is a flowchart, a diagrammatical representation of a program. So in our case, we have to move from this point up to this end. And when you're using a flowchart, we always use this symbol for start. And I think you can see, according to our notes, this is now the start. Then we have the process, we have input, output, decision, and then we have this. We can still have another one that is called connector. And this is the connector that you have talked about, this one, which is called the flow. So in this case, we have the start. When you start, what are we doing? The flow moves to declaring the variables. When you declare the variables, what else can you do? The next thing that you are supposed to do is to enter those variables. So when you're entering, we are using the input or output symbol. Then from there, calculate the sum of two variables. So calculating that is a process. So we use a process. Then from there, display the sum of the two variables. We are using an output. So we use an output function. I have said if you are coding this program or you are writing this flowchart and you find that the program cannot be accommodated fully within the program or within the editor that you are having or the paper that you are having, that is when you use a connector. And if you can look at this, we have said we can use a connector that contains a number of letters that is used to split a large flow chart into smaller parts. So we can use that to separate it into smaller parts. And that's why we are separated or we connect, then we can add. So that is a very small interpretation of a program that is using a flowchart to interpret a pseudocode that we have here. So we are interpreting this pseudocode or these processes that we are having up to the last element or up to the last data that we are having within this presentation. So I think up to now you can clearly understand what we are talking about. Okay, when I say declare a variable, it means it's like we are having a memory. It's like we are having something we don't know. And when you're using something that you don't know, we always assign it a memory. And when you are assigning it a memory, of which we have not started that, of which I will explain further, the moment we'll be looking at the structure of programming language, you look at now, you must define the memory. Maybe I can interpret this. We are having a memory like this, but you don't know what will be stored here. You don't know what will be stored here and what will be stored here. So this memory can be very small. And this memory can be too large, or this one can be very small, depending on the type. So that's why we say declare a variable or define a memory. So you define a memory. And when you define a memory, we use types. One, we can use an integer type. We can use a character type. Then we can use a double type. Or we can use a float type. Meaning, when you use an integer, or when you declare a variable using an integer, we are defining a very small memory. When you use a character, we are still defining it as a very small memory. But when you use a double, you are defining it as a very large memory, but not large than a float. It is large than a float because the float is now in between character and double. So declaring a variable is defining a memory. Right now, we can look at a single room, maybe in terms of the development of the welfare of the current environment that we are in. We can say if you have one bed and you have one chair, an armchair, that is a single armchair. So automatically you can survive in a single room. Suppose you have two beds. Suppose you have maybe three seaters. Maybe you have 3 seaters which are 2, or you have 3 seaters which is 1, and a single armchair which are 2. So automatically in a bed seater, it depends with the size. But now we need to improve the size. So whatever you have in that house depends with the size of the house. If you have a lot of things in your house, automatically you must live in a house that is more in terms of the size. It's very large in terms of size. So that is what we are saying, declaration of variables. And we will see this when you are defining a variable, mostly when you are writing program, because this is a point where now the user is now looking at a point where now we are defining a memory that can be used in the execution. So is there any question up to that point? Can you understand what is declaration of variable? Esther, do you have any issue? Are you understanding what I'm saying about variables, declaration? Okay, no question. Yes, I can see you are typing. Maybe you have another clarification. Yes, I'm waiting for your clarification on that. Okay, so if you have understood, maybe we can look at the C structure. We can look at the C structure, and I think I'll post those notes because I have not posted those notes. I'll be able to post those notes for the C structure because I think I have seen it's not here. Or okay. So the structure of C programming. When you talk about a structure of a C programming, there are things that we need to consider here. So structure of a C program, because now we are using C program. I remember when we are starting the C program, we said we need a C compiler. We need an editor that we can use. We need a memory where we said we can have 1 GB memory, and the hardware that is able to accommodate this program. And most of these programs that we said we can use Dev++. We said we can use Code Block. We said we can use Visual Studio. And that is now one of them that you can still use in coding your program. And in this case, we need to understand further. When you talk about a C structure, that is the layout or the blueprint Sometimes we say it's a blueprint of a C program. We always start with what you call the preprocessor. Preprocessor directive. I will define what is that. Then from that, we have function or functions. Then from functions, we always have what you call the opening block. Then we have what you call the statement or the statements. So this is where we look at now variables declaration. We look at variable declaration. In this case, we look at output display, output, and then we look at inputs, etc. Input, etc. Then after that, we can have maybe some other constants within that. Maybe we can still have some control structures, etc. Then from there, that is where we have the successful completion. So we have return 0 as a successful completion of that program. Then after that, you can have what you call the closing block. Now, those are the things that you expect within the program. So meaning, if you look at the preprocessor directive, we always use hash include standard input.h. So meaning, this is a library. So this becomes a library. At this library, it has all the input-output functions. So we are saying, can you include OR? So this hash means OR. Can you include OR standard input-output headers? So the moment I'm using an input function and I'm using an output function, it can still allow me to do that. Then from there, we can look at this point where maybe I can use this one in a separate point or page. Maybe it is that. Just a minute. So we can have that. So this becomes a library. So in this case, we have a function. One function that is able to call other function is called main. So main is a function that invokes other functions. So you can have functions here. Maybe you can have function 1, function 2, function 3, but this main is the one that invokes all the functions that we have. And when you talk about invoke or invocation, we call. That is the one that is mostly used to call those functions. So allow me to reduce the size of this so that maybe we can have a clear. Then after that, we have the opening. We use the opening curl brace. Can you see this brace? I think it is clear on your side. So if you go to your keyboard, maybe I can expand a bit so that you can see that. So this is the one that we are talking about. We are opening. That is the left curl brace. We call it curl brace. So this one we can call it left curl brace. Curl brace. Meaning, if you use this, we will still come to this. This means it's a comment. It is not executable. It is not executable. So for this case, if you have this kind of an interpretation, just a minute. So you have 28. So for this case now, we have opened a function. We can allow the user to enter the statement. This is where we have the code block. And each code block should end with a semicolon. So then we return 0, close the semicolon. Then after that, you add. And you see now, this one has changed. This is right curl brace. This is the right car brace. So we can say this is the right car brace. And this right car brace means that is now the end of our program. That is the end of our program. So if I try to remove this, and maybe we try to interpret this, we are saying, can you include all the input functions which are in the library of C programming, and we execute them? So when we say code block, here we require some input and output functions. And the input functions that you're supposed to have, or which I will be able to come and explain them, we use them inside the car brace. But before the car brace, we have to use return 0. Remember, return 0, R is small. And when you are using C programming, it is case sensitive. And if you say it is case sensitive, we are saying this program has to differentiate the capital letters and small letters. If you're using the small letters now, and we use the same variable, like now if I say A, or I say A, T, then I use T as a capital letter. These are two variables. So this one is capital T, this is small t. So these are treated differently. So in this case, we must know that this is case sensitive. So in this library, and I want you to do a research on, maybe a research on other preprocessor directives, other preprocessor directives. And when you talk about the preprocessor directive, they should always start with hash include, or they should always start with hash. One of them is hash defined. Just a minute, I respond to this call, please. Just a minute, I respond to this call. So I'm sorry for that. So what we are saying is that if you look at the program that we are having, we can use other preprocessor directive. One of them that we can use is hash define, maybe pi 3.142. That is one of them that you can use. And maybe we can use another one, hash include, maybe io manip.h. Maybe we can use another one, hash include string.h. So when you look at this, we are saying we are manipulating input output. This is when we say maybe we set width maybe to 3 of a certain value. Maybe you can set width to be 5, set height to be 6. So we are trying to manipulate some input values. This one, we are saying we need to use a string function somewhere, but this string function, it is in the library called string. So one of the strings that you can have is strcpy. So strcpy. strcpy, we will see it in our functions. The moment we'll be writing programs in a function or string functions, where we are saying, can you copy a certain file? Maybe we copy A to B, or we copy B to A. Copy something that is in B. If you say B is equals to 1 and A is equals to 4, so we are saying, can you copy 1 to variable A? So in this case, we can use this preprocessor directive. So I want you to research others, their functions. We have others like hash error, hash if, and many others that we have, so that you can see maybe what are the functions of those preprocessor directives that we are supposed to have within our code. So that is now a bit presentation of what we have within the preprocessor directive. But the moment I want my program to execute, I must use the main program. So this is a structure that allows you to code a program that can allow you to execute all the functions, all the statements that you have. So here we can say we are having the code statements. At the moment you are having the code statements, these statements can be variables. These can be input stroke output functions. Maybe it can be other statements like maybe the control structures. It can be the control structures that are supposed to be defined there. Then we have return 0. This return 0 means successful completion of the program, successful completion of the program. We have completed our program. The next step is now to do another thing because we have already terminated the execution. If you have understood this, and I will wait for your response, maybe the structure, the forum. So this one is a must. You should use this. It is a must. This one is still another must, but I want to elaborate this. And when I'm elaborating this, I have started with main, or I can say int main. So this is a function that returns something. So we are saying it is a function that returns something. Function that returns something. And if it is returning something, if you are using main or int main, it's the same. You must end with return 0. We must end with return 0, not return or. It's return. It is not return or. It is return 0. And the next case, if you are using void main, and we open now these blocks that we have here. Now, it is not a must we use this return 0. So we don't use return 0 if you have said void main. We know that it has already completed the execution. But for this, we must see the successful completion of that program, given the code that we are having. So that is something that we are supposed to note in the execution, or that is something that we are supposed to make sure that you understand within the execution when we are having such a scenario. So I would come back. I want to come back to you. Maybe you respond to what we have done, and you tell me whether you can understand our structure so that we can go to the next part of our coding that we call the input stroke output functions in C programming. Input output functions in C programming. Are you now okay with the structural way of writing a program? Are you okay with that structure of writing a program? Because I want us to end to those input output functions. Then from tomorrow, from next week, maybe we can start with variables. Are you okay with that? So as you respond to the question, I want to open an online editor that we can use maybe to code that program, and we see how it works or how it is given out. Don't use that, use this. So if you look at this program, are you okay? Are you okay with what we have covered for now? Okay, if you are okay, I want to show you on how the program should always look like. So remember, this is the hash include. This is a must, but the other libraries that we are using, if you're not using one of the functions that requires those libraries, there is no need of using it. Then we have int main. This means that we must have a return 0 somewhere because we have used the int main somewhere. We are opening this bracket and we are closing the bracket. So this is a very simple program which is using an output function. And that is where we are now coming to. And I don't want to explain this in a code. Allow me to go to the PowerPoint so that you can understand how we can have the input-output function. And I want us to start with output functions. Output functions. One of the output functions in C programming, we have printf function. Printf means print file. This we have the opening bracket and closing bracket means that is a function. Then we have what you call the putter function. Those are two functions. Remember, when you're using any kind of a presentation in C programming, make sure that you use small letters. Make sure that you use small letters because it is case sensitive. So this printf function, we are saying, can you display all the statements? All the statements either represented as character, comma, as integer, comma, as double, comma, as float in the program execution. At the moment I say putter, so display all the statements. Sorry. So display the statements which are declared as characters. And characters in C programming, we use char. So declare all the variables, all the statements, display all the statements which are declared as character. So if you declare it as a double or as a float or as an integer, automatically it cannot be displayed using this. So for this case, when you're using the printf function, we must use a string. So we are saying this is good. So this should be displayed the way it has been displayed. So they should be displayed, this is good. The same case to this. So if you look at now the input is used to enter data. Input functions. And in input functions, we have scanf function, scanning file, printing file. Then we have get char function. This one is for all int. So you're entering int character, comma double, etc. But this one is for only character. We allow the user to enter only characters. Only characters. So in our programs, we mostly use scanf and printf. Because when you're using these, we always say that the scanf is for all variables. So even if I'm using a character, even if I'm using a double, even if I'm using an integer, I can use one of them. But now for this one is trying to create a segregation on the usage of this data. So for this case, we allow now to use different kind of data presentation. So for this interpretation that we have, and I think you can see this called a presentation, sorry. We can see this. We are having printf hello world. If I try and execute this program, what am I supposed to see? Hello world. That is the output that you are supposed to see in our editor or compiling editor. So I think we can wait as it executes. So in this case, when we are using these input and output functions, we must end with a semicolon. All statements must end with a semicolon, meaning the end of that statement. By the moment I use a comma in any execution, suppose I am declaring int A, comma, int B, then I have semicolon. I'm saying A, and I declare int A, then I have a comma. I'm saying we are continuing. So, comma, maybe we can write this. Maybe let me use, that is a comment. It cannot execute comment. So you can say comma means continuation. While semicolon means end of the statement. End of the statement. So just a minute. So for this case, what we are saying is that if you look at this program that we are having here, we are having a semicolon. So if you remove this semicolon, and maybe we say we are executing this, this is the one that it was executing, this program cannot execute. If you try to execute, let's see, it cannot execute. This results to a given error, and this error, which is as a resultant of missing semicolon, improper language use. Maybe I'm supposed to use int, then I use 8. That becomes an error. Improper use of language result to what you call syntax error. So that is a syntax error. So if you look at this program, let's see whether it has executed, of which it is not supposed to execute. Can you see? It's saying in function main, error expected before return 0. Error expected before return 0. And this error is just a semicolon. That is what you call dry running. So you must first of all dry run. When you dry run a program, you move from the first statement, looking at all the requirements that are supposed to be there. Are they there? If they are there, now we can move and we can try to execute that program. So if you try to execute this program, it's supposed to give you the code. So in this program, I can still add some presentation. Maybe I say, hello. Just a minute. So I can say, hello, Esther Akinyi. You have attended the class. So I can write anything. Then after this new line, maybe I can write, please make sure you tell others. If I try to run this program, it will not display hello world. Hello, Esther Akinyi, you have attended the class. Please make sure you tell others. Please make sure you tell others. So this is now our own interpretation. I can still use some asterisk, or maybe I use some coding. Maybe I'm using some presentation of coding. Maybe I want to make some design on that. And then I execute this program. It's supposed to display the way I have written that. So these are the columns that I have already displayed. So in this, that is now when you're using the output function. And that's why we are saying we use the output function mostly when we are using the printf function. And that's why we use the printf function. Are we together? Okay, I can repeat on what I have said, syntax error. So when it is a syntax error, what we say is that we have missed the right information. And because we have missed the right information, what we are saying is that if this is the program that we are supposed to have, suppose there is a program that we are supposed to have, and this program is supposed to maybe to have this. I will explain this. Don't mind about this. There is a new line. It means there is a new line /n. There is a new line. So if I'm using this kind of a presentation, and I fail to use a semicolon, that is the one that we are saying it is a syntax error. Omission of the right symbol or grammar that is supposed to be there. If I come here and I say ref, and I have a semicolon here, this program is not supposed to execute because it does not allow what is a lintf. So this is an error, and this error is a syntax error. So a syntax error is an error that occurs because of the improper language use, either omission of symbols or omissions of the right character or data that is supposed to be used in a given programming language. Are you understanding that? Can you understand that now? Can you understand? Do you have a class in the afternoon from 2? Do you have a class in the afternoon from 2? Okay. What I'll do, let's end at that point because in the scanf function, we require a lot of explanations in scanf because we need to have the inputs, the memory allocation, and the memory addressing. The memory allocation and the memory addressing. So allow me to start from scanf next time, and I will send notes to your portal. Is that okay? So that you can prepare for the next class. And please, if you have any challenge, you can tell me before time so that we'll be having the right class in the right time. What I have said is that at your own free time, just go to the operating system, and there is a quiz that I have already sent. Just do that quiz, and maybe I can set that quiz up to Saturday. So you do from today, tomorrow, and Saturday. Then you'll be able to click submit. Then we see what is the progression on that so that I can give you cut 1. Is that okay? Yeah, so let us meet next time.